we started this project, we had a facility that was set out originally for testing internal combustion engines. So therefore it had some of the capability that we needed in terms of the dynamometers and the space to mount electric machines. But our brief was to make that facility available for electric machine testing, which of course involves a lot of different test equipment and a lot of different things you actually do on the dynamometer rig. Therefore, we wanted to be able to get all of our existing equipment into the same test system and have it all controlled by the same system. That way we could get everything under a single user access, and also the test system would be capable of integrating the functions. So even during a test, we would want to be able to make real-time adjustments in response to something else that we'd measured perhaps. So we had this equipment already. We had some chillers for controlling temperature, we had dynamometers, we had the cell services which provide the ventilation through the system. We also had test inverters for putting onto an electric machine, but they were all separate systems and they were all operated through different communications protocols using different types of buses. And we had no way at that point to have this lot under central control, and that was one of our key drivers for the project. We wanted to bring everything into a single point. So not only did we want to be able to have all our pieces of equipment connected together, we also needed to bring in more equipment. We needed further power analyzers and thermal measurements which were applicable to electric machines. And that was another one of our requirements into the system, as we must bring in more equipment. Finally, we wanted a system that was able to monitor what's going on in real time with high accuracy, high fidelity, and also be able to run processes such as scripting and real-time models so that we could actually influence testing in real time.
So I joined WMG to develop the research team on electric machines, especially dedicated to the automotive industry. It became really clear from the beginning that we needed a state-of-the-art testing capability that would both allow us to collaborate with the OEMs and repeat the tests they need to deliver, but as well meet our needs in terms of research, requiring a lot of flexibility with the type of test and control we needed to apply to our testing objects. So we already had some hardware, but dedicated to testing of combustion engine. And if we could keep the hardware and the facility itself, it became clear really soon that we needed to have a better control system adapted to our needs. And Austin was by clear giving us the best value for money, both meeting our needs and being within our budget allocated for the kit.
Some of the key issues that we need to consider when selecting a test system is the fact that we are a research centre. So as such, we have a wide variety of different research activities, and essentially the technology we work with is evolving very, very quickly. So adaptability, future-proofness, if you like, and the ability to change the technical requirements or the overall system functionality is a key aspect of what we need. The reason for choosing the Austin consultant system was essentially its adaptability and the amount of engineering effort that the team put into it to ensure that the key criteria I've mentioned previously were met. So adaptability, being able to future-proof the system, and also to be able to modify the system functionality for any type of research that we get through the door.